In modern times, many people are fascinated by the idea of colonizing Mars. Life evolved here on Earth, giving rise to a tremendous amount of variety in almost any environment. However, as far as we know, life has yet to expand beyond Earth's atmosphere, and it's not hard to understand why. Breaking out of Earth's atmosphere is extremely difficult, and requires massive amounts of energy. Plus, once you reach beyond that point, the environment becomes significantly more hostile than most places on Earth's surface. Evolution requires a gradual adaptation, and these barriers are simply too high to easily climb. But this may be about to change. Because of humans' ability to adapt, plan, and innovate, humans have explored beyond the barrier of Earth's atmosphere, allowing humans to walk on the Moon, control robotic rovers on Mars, and even temporarily live in Earth's orbit on board the International Space Station. More so, humans have plans to go even further, sending humans to, and even colonizing Mars. Unfortunately, Mars is not a very comfortable environment for humans, or much any other living thing, and requires very expensive machines and equipment, sent from Earth, just to have a minimal existence there. However, there is one species of lichen that has been found to tolerate the harsh conditions of the Martian surface. With the name Pleopsidium chlorophyllum, this species of lichen naturally survives on rocks in dry, Arctic environment where ultraviolet radiation is already higher than normal. It is a very slow-growing species, and under the conditions of a Martian environment, even this species has a hard time. Under direct exposure to Mars radiation, it can do nothing but barely survive. However, in between cracks and crevices of rock, it can shield itself from much of the radiation, and actually grow. This has the potential to spread DNA-based life beyond the current confines of Earth, which many people agree is a valuable idea. Not only does it offer some protection in the scenario that something causes all life on Earth to go extinct, but it will also help to terraform Mars, helping to provide valuable real estate for future human growth. Plus, there are scientific advantages. Unlike Earth, all environments on Mars are wide open for establishing new life. It can be assumed that, once life gets a foothold, a wide variety of new species will evolve, leading to an explosion of new species on Mars. This would be an amazing opportunity to study how living things evolve, and to see what kinds of genes and traits can be beneficial in a Martian environment. I believe a key task in such a circumstance would be to begin selective breeding of new varieties of lichen that can better withstand Mars-like conditions. This can be started now, as no new technology or financing is required. I think many people would take interest in growing their own variety of lichen, if they know that their variety may very well colonize Mars in the future. It would only take someone to design a simplified closed environment that replicates some of the important conditions found on Mars. Predictions can be made about how lichens will evolve after they establish themselves on Mars. Since tests have shown Mars radiation to be one of the strongest inhibitors of the lichen's growth, it can be assumed that this will be one of the first problems that the lichen begins to adapt to. The lichen may develop more UV protective molecules to help it cope with the radiation. However, this may or may not be enough. Another possibility is that it develops a skin-like shield to protect it from direct exposure. This will allow the lichen to spread beyond the confines of rock crevices, opening doors for further opportunity. Because Mars is so vast and empty of life, species that can disperse the farthest and fastest will be giving the strongest evolutionary advantage. On Earth, a common and simple solution to this kind of problem is the tumbleweed. Since Mars is already known to be capable of very strong winds, the first species capable of utilizing these winds will be quick to colonize the whole Martian planet. It's not hard to see how a tumbleweed-structured lichen will develop. After the lichen has a shield-like structure to protect it from radiation, it can slowly begin to creep out from rock crevices. Large pieces that break off from this protrusion will fall off, and possibly be carried a short distance by wind. However, lichens that prepare for this, and create structures that will be better carried by wind will be dispersed even further away from their origin, reducing their competition with other lichen. These tumbleweeds will likely be the first common form of life on Mars. So then, Can it be assumed this will begin to make Mars green? The short answer is no. Unfortunately, Mars simply lacks enough water. Just like deserts here on Earth, life can only grow as much as it has access to water. This is a problem at the basic molecular level. The synthesis of organic molecules requires at least two simple ingredients: carbon dioxide and water. Carbon dioxide is abundant on Mars, but a source of hydrogen is needed in order to utilize this carbon. Without hydrogen, organic molecules cannot be synthesized. It's very possible to establish DNA-based life on Mars, and I am a strong supporter of such an idea. However, until water can be made more abundant on Mars, Mars will continue to remain a desert environment at best.